In this video, we'll talk about logarithms on like an introductory level. We'll also talk about how to convert from an exponential function or an equation to a logarithmic equation and vice versa. So the first question is, what is a logarithm? And if we think about an exponential function, so basically we have y equals b to some power of x, where b is a constant. This would be an exponential. Well, a logarithm would be an inverse to an exponential function. So a logarithm is the inverse of an exponential. And if we think about that's pretty difficult to pull off, because if I think about trying to make an inverse for y equals b to the power of x, well, how do I get x by itself? How do I make this possible? Because if we follow our idea of trying to make an inverse, well, first thing we would do is we would switch our y's and x's. So x would equal b to the y, and then how do I get y by itself? Well, we could try and take a y-th root, I guess. But then how do I get x by itself? And this presents a lot of questions. So mathematicians have decided that what we would do is an inverse. So if f of x is equal to b of x, then f inverse of x is going to be log base b of x. And we'll talk a little bit more about what that means, but in essence what we've done here is just explain that mathematicians say, okay, let's let that be the inverse expression, because we don't necessarily have the tools to deal with this thing algebraically. So we invented it. That's basically what a logarithm is. It is the inverse of an exponential. And we'll talk about some applications here, and this is very much an introductory level, but logarithms are very, very powerful tool in mathematics. So a lot of the power stems from the fact that you can convert an exponential equation into a logarithm and vice versa. And sometimes when you're trying to solve an exponential, you run into a point where you don't necessarily know what 2 to what power would be 57. I don't know. It would be very difficult to determine. However, we can convert it to a logarithm and it becomes much easier, and vice versa. If we're trying to solve a logarithmic equation, we may hit a brick wall somewhere. We might want to convert it back into an exponential. So I use an example to help myself determine place for converting. So I use the example 2 cubed equals 8. This would essentially be my exponential example. And this is true if and only if log base 2 of 8 is equal to 3. Now, keep in mind, that's my input originally, and 8 is my output, or my x and my y. And if we're doing an inverse, they flip. So, a way to keep this straight. The bases are the same. We would read this as log base 2 of 8 equals 3. And we can make the conversion. Here's our base. So if I have a base 2, well, it'll be log base 2. It would make sense that every exponential function changes depending on the base as far as picking what family for exponentials. Likewise, logarithms have to have the same kind of thing going on. They also have to alter because they're based on exponentials. Your power becomes, well, the end of the equation, I guess, for the logarithm. They switch. And then 8 goes on the inside of the logarithm. So this would be, I guess, the, I don't know what term you would put on it, but it's the 8 in this case. So this is an example I use. I write it down all the time, it helps me keep track of if I'm converting from an exponential to a logarithm and vice versa. I know where the pieces go. And you may notice all these arrows and it might be a little confusing, but just write this part down whenever you're working with exponentials and logarithms, and it'll be an example to follow if you decide, okay, I want to convert. So let's do an example. I'm going to go ahead and write down our first example. So 2 cubed equals 8 if and only if log base 2 of 8 is 3. That's just an example, totally separate from the question. And the idea is I want to convert this into a logarithmic equation because I don't know what power 2 has to be to make 7. I just don't. So then we're going to rewrite it instead as log base 2. The bases are the same, so got to keep that. And then instead of putting x in here, I'm going to put 7, just following my example, equals x. Now we will learn some tricks as to how to evaluate this expression. It's actually very, very doable. As opposed to this equation, I don't necessarily know what to do with that. But for now, all we're worried about is the conversion. So this is finished at this point. So let's take a look at another example. In this case, we have a logarithm and we want to work it backwards to be an exponential. So again, I'm going to write down the example that I use. 2 cubed equals 8 if and only if log base 2 of 8 equals 3. So in this case, I have a logarithm. I want to go back to an exponential. So what I have, log base 5 of x equals 8. Well, this means that I'm going to have 5 to the power of 8 is equal to x if I work it backwards. And this would be my exponential. Now this is a much easier thing to work with. I already have 5 to the 8th power. I can do that. That's much more doable than this. So sometimes it's beneficial to convert. It makes it easier to solve because these equations have the same meaning, even if they look a little bit different. So this video, all about conversions. We're not so much worried about solving just yet. We'll build those skills, but there's some more understanding we have to have about logarithms in general before we can use them to truly solve equations. And we'll get there.